We're going to play around with coins and Plinko to figure out where the binomial distribution and the normal distribution actually come from. We're going to start out with coins. So imagine you have a standard quarter and you flip it and it can come up either heads or tails. So on your first flip you can get either a head or you can get a tail. We'll scroll down a little bit here. Now if you were to flip the coin again, there's two possible options, either heads or tails. And if you got a heads the first time, you could get a heads again. If you got a tails the first time, you could get a heads. If you got a heads the first time, you could get a tails. And likewise, if you got a tails the first time, you could get a tails. So you could go tails, 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 heads, heads, tails, heads, heads. And this process repeats. You can flip it a third time, and you can get either heads or tails. And then out of each of those, you can flip it a fourth time, and you can get, of course, heads or tails. And you can do that for each one of these. I'm going to fill that out real quick. So there you go. Here is all of our possible options. And as you can see, with 4 flips, we have 1, 2, 3, 4, 5, 6, 7, 8, 16 different possible outcomes that could occur. And just to go through how we figure out what those are, we follow the tree. Heads, 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 heads. And then we'd have heads, 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 tails, and you'd repeat that for all 16 of these. And I'm going to just write these over on the side. So the first one is heads, 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 heads. Second one, heads, 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 tails, and so forth. And here are all 16 of our different possible outcomes that we could have if we flip the coin 4 times. Now what I want to see is, let's organize this into how many ways can we get a certain number of heads. So yes, there's 16 unique outcomes, but how many ways can we get 0 heads? Well, the only way to get that is if we get all tails, and there's only one way to do that. So put that in there. But what about 1 head? If we look through our list here, we see that there is 1 outcome here that has 1 head. We have another one, and then 2 more. So we actually have 4 different ways to get exactly 1 head if we flip a coin 4 times. So we'll put those in there. Now what about 2 heads? We actually have 1, 2, 3, 4, 5, 6 different ways to do that. So 6 ways to get 2 heads. So we can put those all in there. Now we're back to 3 heads. And we look at that, 1, 2, 3, 4. So kind of our last ones that we have left here, other than our final one, which is 4 heads. And the only way to get 4 heads is to get, obviously, 4 heads in a row. So it's just this one way. So if we have to write down how many ways there are to do each of these things, there is 1 way to get 0 heads. There's 4 ways to get 1. 6 ways to get 2 heads out of 4. 4 ways to get 3 heads out of 4. And 1 way to get 4 heads. So if we flip a coin and it has a 50-50 chance of coming up, yes, 2 out of 4 is what we expect to get. That's the most common one. And you can see here that is the most likely option of all of these, to get 2 out of 4 heads, given that it's 50-50. However, it's not exactly going to be 2 every single time. Sometimes it's 0, sometimes it's 4, and sometimes it's something in between. So what the binomial theorem does is it allows us to predict how likely different outcomes are overall in a series of trials. So in this case we had 4 trials. Let's jump into Plinko. So the game of Plinko is this game from The Price is Right, where you have a disc and it falls either left or right down a series of pegs in the board. And so I will get to that in just a second, but first we're going to look at The Price is Right. So here we have someone playing the game of Plinko, and he's dropping the puck in, and it bounces down the pegs and it falls into some slot. And so jumping to the punchline, let's go watch him in one of his final shots here. It bounces, and it's going to fall into one of these slots. Oh, let's watch that again. And there is a winner. So what are the odds of that happening? That's actually something you can calculate. So with this little disc here, you follow it down and it has 2 options here. Just like the coin can go heads or tails, this Plinko disc can either go to the left or to the right, and it has an equal chance of going either left or right. And let's say it goes left. From there, it has a choice to go again, left or right. Same thing if it went to the right originally, it has the choice to go either left or right. And so now, there's two ways for it to get here. It could go this way, or it could go this way, and it could get to the same spot. There's only one way to get to each of these ends. It's kind of like how many ways are there to get, if you flip a coin twice, how many ways are there to get exactly one heads? You can go heads tails or tails heads. So it's very similar idea. And if you keep going with this Plinko chip, this far one here is going to have two options. This one here, you've got two of them there, so both of them could go left, both of them could go right, or one could do each. You got this one that could go left, this one that could go right, and now we have one way to get on the far end, three ways to get here, and one way to get on the end. And then from this one, it could go to the far end, or it could go to the right. Of these three, the three could go left, could go right, or there could be some mix of some going one way, some going the other. Same thing here, you could have three going one way, three going the other, or some mix of those. And then your one is either going to go left or right. And if you total it up, you have one way to get in here, you've got four ways to get in this box, 6 ways to get in the middle, 4 ways here, and then one on the end. So if you're trying to figure out what's going to win you the $10,000 prize, it's actually the most likely outcome out of all of them. But if there's a total, if you add these up, there's 16 different ways you can make it down the pyramid. Only 6 of them take you to that middle one. So yes, it's the most likely. No, it's actually less than a 50% chance you're going to win it. If you add up all the ways to win money here and all the ways to get nothing, it looks like there's 8 ways to get nothing and 8 ways to win money. So it's interesting when you play through the different possible scenarios and kind of see where they go. They're not always going to go where you expect. One thing that's cool, if you remember Pascal's triangle from an Algebra 2 class or just somewhere else, maybe you don't check those things out on the internet, but Pascal's triangle is this mathematical idea of you start with a 1 on top and then you keep adding new rows and you put 1s on the end, and to get the numbers below it you add the 2 numbers above it. So to get this 3 here you add the 1 and the 2. To get this 6 you'd add the 3 and the 3. And every number on this pyramid is created by adding the 2 numbers above it. And it turns out it's exactly the same concept here as this Plinko game or as a coin. And not only that, but it's also the same idea as the binomial theorem or the binomial distribution. One cool thing is that if you decide to pick any given row and draw a quick graph of what it's going to look like, as long as you get a little ways down, you're generally going to see a peak in the middle and overall some kind of symmetrical shape. Here we have 1, 3, 3, 1. The middle gets a little bit taller compared to everything else, and the bottom's a little shorter. Here 1, 4, you have your little 1, your bigger 4, your 6 is up a little bit, and you'll notice that it kind of resembles a normal curve. Let's continue on and see what this would look like if we did 30 coin flips. So not just 4, but we did 30 coin flips, or we took 30 rows in a game of Plinko. What would that end distribution look like? And we can actually simulate that using a calculator, using combinations. So in my calculator, I'm doing combinations for row 30 of Pascal's triangle. And if I graph it, holy moly, check that out. It forms, you guessed it, the normal curve. So if you're wondering where the normal distribution comes from, it's actually based on the binomial theorem, just repeated lots and lots and lots of times. The one way to think about that is if you take something that's normally distributed like height, and you say, well, where does height actually come from? Well, it's a whole bunch of factors that are kind of like flipping a bunch of coins. For example, you have a bunch of different genes within your own body, some from mom, some from dad, that mix in different ways, and each of those interactions, each of those genes is kind of like a coin flip. Then you have the environment you grew up in, what you ate and drank as a child, all kinds of conditions that are could be effectively like a 50-50 shot whether you did or you didn't. And if you take that over the entire population of the world, all those little 50-50 decisions, all those little coin flips, it'd be thousands of them, thousands of these coin flips, maybe millions. And as you get to any large number of those decisions, 30 is enough to make almost a perfect normal curve. Thousands of such decisions is also going to be normally distributed. The normal curve versus the binomial theorem. When are you going to use each one? Well, the normal curve is for those situations like height, where in the population there's lots and lots and lots of these decisions that kind of determine one outcome. How tall are you is determined by many different things coming in. Binomial is a lot more straightforward, single outcome. So for example, I'm going to flip a coin, and each coin flip has exactly 0.5 probability of landing on heads. Or I'm going to shoot free throws, and each free throw I have an 80% or a 0.8 probability of making it, and then I'm going to shoot 10 free throws in a row and see how many I can make. Things like that. When you have a very specific probability that you're starting with, that's generally when you're going to go with the binomial theorem. When you have something where there's many repeated factors, many hundreds or many even thousands, and the overall population follows this pattern, you're going to just assume that it's normal and use some shortcuts with the normal curve. To see how to do the actual calculations, see the videos on the binomial distribution. There's also a module on the normal distribution, and there's a bunch of ways to do calculations with those.